Hello, I am James Walters with the Air Conditioning, Heating, and Refrigeration Institute. I'm very pleased to be with you today and to talk with you about how to choose the correct refrigerant. The suggestion I have for you in that respect is choose very carefully. AHRI is an association of manufacturers from around the world, 300 manufacturers headquartered in virtually every continent in the world, producing cooling, heating equipment for residential, commercial, and industrial applications. This is detailed on the slide that you are looking at the present time. AHRI is located in the United States in Arlington, Virginia, which is directly across the Potomac River from Washington, D.C. I specifically want to direct your attention to one of AHRI's task forces, the AHRI Safe Refrigerant Transition Task Force. The task force is charged with looking at and examining low global warming potential refrigerants for direct HVAC applications. The responsible staff person, Helen Walter Terranoni, is listed below the title, as well are links to the websites of the task force. With respect to the work of the task force, there are over 200 members from more than 70 associations. Their task is to identify and resolve issues related to the transition and, very importantly, to build on programs already in place around the world. It is open to interested stakeholders. It is not about doing everything over. It is about recognizing, cataloging, and building on what has already been done. The areas that the task force looks at are outlined in the blue blocks to the left. So this transition to low GWP refrigerants, some things are the same. The majority of the physical and chemical properties of this new class, A2L, of refrigerants, excuse me, are no different from traditional A1 refrigerants. However, there are some differences. Low GWP refrigerants include some lower flammability, class A2L, and higher toxicity refrigerants. And what we need to know about it is that stakeholders must be aware of, properly trained in the mitigation of risks due to the lower flammability or higher toxicity properties associated with the new refrigerants. As stakeholders, we need to look at regulatory, safety standard, and building codes that exist, the current roadmap, and see how that they can be revised and applied across different jurisdictions. Training has to be shared internationally. And as always, there has to be significant communication and network to ensure that we share and leverage learnings from one another. The goal of standards in this particular activity, quite simply, is to prevent ignition. In order for a refrigerant ignition to occur, there has to be two failures. The refrigerant leak must exceed the lower flammability limit, LFL. 10 to 14% LFL concentration, large refrigerant release. And there must be a competent ignition source, minimum ignition energy, in an area that exceeds the LFL. Has to be an open flame or a very high energy ignition source. The goal of the standards is to prevent the LFL concentration from being reached. This can be by refrigerant charge limits or mitigation requirements. Mitigation may include circulation or ventilation to reduce refrigerant concentration, and of course, removing competent ignition sources. Safety standards are key to the effort. In the blue blocks above, you see, in general, the accepted process. Survey the standards as we know them at this time. Identify the gaps. Do research to fill the gaps. Update the standards with that research, and then publish them through a consensus process to ensure acceptability and wide distribution. Already, there's over $7 million worth of research results available in the United States, and current research from all over the world will support optimization for future projects. The objective is quite simple, related to the safe use of flammable refrigerants, and make results available for public safety and awareness. I'm sure that you've seen this chart or something like it before. For the purpose of this presentation, is there just to give us a reminder of the change in characteristics from 1A1B1 to A3B3, toxicity, flammability, etc. A2L's refrigerant ignition properties are, I'm sure you're familiar with. A2L refrigerants are difficult to ignite. They require high ignition energy. They require higher levels of concentration to be flammable. They also have lower flammability characteristics. This is very important. Low burning velocities, low heat of combustion, and they do not always fully combust. In looking at A2Ls, the fundamental approach to prevent ignition and combustion are these 8 steps. I certainly will not read them all to you. You're probably familiar with them. I will emphasize number 8, and I'll come back to that later. So important in this transition is service training and education. That is an area that must receive additional unprecedented emphasis. This is simply a diagram that shows the safe application of A2L refrigerants. I'll fill it up with a very complex series of notes, which you are free to read at your free time, but they basically cover pictorially what I just reviewed. This is a summary list taken from UL 60335-2-40. Requirements running through A1 through A2 and 3 with comments on those things that are required and not required, those activities. Again, this is a list to look at very carefully as part of preparation. Earlier, I talked about research that has been done. I've included a sample of many studies done by the industry, AHRI, ASHRAE, the laboratory, the U.S. laboratories. This is a sampling. All of these are available for review. Some of the results may already have been incorporated into standards or studies. And it's not a comprehensive list. Other studies have been done by the National Fire Protection Association, studies in Japan and Europe. There has already been a lot of work done, and that means a very careful identification and cataloging of that work distilled into safe operating practices. In selecting lower GWP refrigerants, the process can be complex. Of the many factors in that process, the top 5 are emphasized. You have to look at the direct GWP focus. Certainly in the United States, that's an EPA focus. Indirect global warming, and looking at the effects on energy efficiency at power plants, toxicity, flammability, and material compatibility. All of these areas are important areas to examine, to be aware of, and understand the correlation among the many factors in moving to low GWP. As an example, one company alone has evaluated 431 refrigerants for 20 different system types. AHRI is working with UN Environment to conduct and build a program that will result in what is called the refrigerant driving license, the RDL, which will be a curriculum and a guide for technician training in Article 5 economies. The training qualification program will be globally recognized and accepted. The program will set minimum requirements for the sound management of refrigerants by the supply chain network. If you wish additional information on any of these slides or in this program in particular, contact me, Jim Walters, at ahrinet.org. I'll be happy to fill you in. So in conclusion, there are no surprises. How does one choose the correct refrigerant? And the answer is still, as from the beginning, carefully, or we might say very carefully. Thank you. Shukran. Merci.